All right, so this is going to be a lesson on topic 3.3, interpreting slope on motion graphs. So the do now question here says, what section, right, which section of this position time graph represents an object at rest? Well, how can you tell? And how can you tell? Well, if we take a look at my y-axis, right, if you're at rest on a position time graph, if you're at rest, your position will not change. The only 2 points that shows you something that's at rest is the points starting at C and the point ending at D. Because you see that at each point on this line, my position does not change, which is what my y-axis is measuring here on a position time graph. I call this position because it is essentially position. Displacement is your position over time. So I'm essentially at each point in time here, each point on my line, I'm staying at a constant position, right? My position is constant here. Uh, so 1A, now let's go to the next slide. So based on 3.1, what does the slope of a position time graph represent? Now let's say you don't memorize it, right? So you don't memorize what that means, what the slope of a position time graph means. Well, what you can do here is that as long as you know that slope is essentially your change in y over change in x. Well, what's my y here on this position time graph? Right, my y is my displacement, right? This is my y, and I measure my y-axis in meters. And on my x-axis, I have time. And so I measure my time, my x-axis in seconds. And so my unit here is meters per second. Right, my unit here is meters per second. And that, well, what is this a unit for? What is meters per second a unit for? Well, meters per second is a unit for velocity, right? So we know that on a position time graph, the slope gives us velocity. And here you didn't really need to know, you didn't really need to remember it, because all you needed to know was, well, what is slope? Slope is y over x. Well, if you do the unit divided by the unit, you get velocity. So let's move on to the actual, we want to talk about positive and negative slopes here, right? So we want to talk about positive and negative slopes. But let's first talk about, well, what is this graph telling you? This graph is telling you that from at 0 seconds, my position is 0. So I'm at 0 here. And at 1 second, my position is 4 meters. And my position is 4 meters. And at 2 seconds, my position is 8 meters. And at 4 seconds, my position is still 8 meters because you don't move anywhere, right? So at 3 seconds, my position is still 8 meters. I don't really move. At 5 seconds, my position is at 6 meters. So I finally move backward, right? I'm going back now. At 6 seconds, I'm at 4 meters again. And at 7 seconds, I'm at 2 meters. So that's the type of motion, right? So there's this object is moving in the positive direction, standing still for a while, and then it's moving in the negative direction again. All right. So now, but we have to figure out, well, which section shows you a positive slope, and what does that mean? Well, you should know that an upward slope represents positive slope. So let me show you what an upward slope means right here. Right, so if you have an upward going slope, you will have a positive slope. And if you have a downward slope, right, if you have a downward slope, you will have a negative slope. So going back to the question, which section shows you a positive slope? And what does that mean? Well, from a time of 0 seconds to 2 seconds, I have a positive slope. And a positive slope, if we know that slope on a position time graph means velocity, then we know that a positive slope means a positive velocity. And a positive velocity means that you're traveling in the positive direction. And you're traveling in the positive direction. All right. Now, let's look at the bottom. Let's look at the bottom one. Which section shows you a negative slope? So your negative slope would be your downward slope. So from a time of 4 seconds to 8 seconds, you have a negative slope. Right, so which means you have a negative velocity. You're moving backwards now. So you're moving in the negative direction now. So you're moving in the negative direction here. Negative direction. So that's the answer to these two questions. All right, so let's move on. But now we have to differentiate between two other types of slopes, right? So there's this, you see this line here, there's the straight line, and you see a changing line, essentially a changing slope. So the blue line here is a constant slope, whereas the red line is something we would call a changing slope. So let's kind of figure out what the difference here is between these two. Let's try and calculate the slope of this blue line, right? So again, your slope is essentially your change in y over your change in x. So let's calculate the slope at 1 second. My change in y is 2, or rather, my change in y is 2 and my change in x is 1. So if you do 2 divided by 1, right, you get 2. If you do 4 divided by 2, you get 2 here. Right? And if you do 6 divided by 3, you still get 2, and so on and so forth. And you can say that, well, my slope here is constant, right? My slope here is constant. And well, what can we say about the velocity of the object on this line? Well, constant slope means that my velocity is constant. Right? You have a constant slope here. And if on a position time graph, your slope is your velocity. So I have a constant velocity if I have a constant slope. Now the red line here represents a changing slope. So what can you say about the velocity of the object depicted by the red line? Now this is not something you can do right now, because if you can't really calculate the slope of a curve unless you use calculus. And because you guys don't know how to use calculus, I'm gonna teach in a way that isn't the correct way, but will highlight what I want you to understand. Now, I highly stress this, do not do this in your math class, because this is not the correct way to calculate slope of a curved line. So let's do y over x, right? Let's do y over x. So my y here of this dot is 1, my x is 2, so 1 divided by 2. My slope is 0.5. Let's take a look at this point in the line. 4 divided by 4. That gets me 1. And then let's look at this line right here, right? And it's 8 divided by 5. And that gets me 1.6, right? So I'm taking my y divided by x, and I get this number right here. So as you can see, you have a changing slope, and well, if we know that a slope on a position time graph gives you velocity, well, a changing slope means you have a changing velocity, which in the physics term for changing velocity is that you are accelerating, right? You are accelerating, or you have an acceleration. You have an acceleration. So that's essentially the difference, right? And this is a summarization. In a position time graph only, a constant slope represents constant velocity. A changing slope represents changing velocity. And this means that the object has an acceleration. Let's go into box 2, slide 2. What does being at rest look like on a position time graph? Right, so let's take a look at this. So if you're at 5 meters, right, and you're assuming your initial position to be 5 meters, so your initial position is 5. And if you're not moving, if you're at rest, if you're at rest here, well, at 1 second, if you're at rest, you're not moving. Well, I'm still at a position of 5 meters. At 2 seconds, I'm still at a position of 5 meters. At 3 seconds, I'm still there, and so on and so forth. And you get this line essentially when you're at rest. That's what you get. But let's take a look. Now that you understand that, right? You know that being at rest means you see that kind of line. We have to kind of interpret, well, what do these curved lines on this graph mean? What do they mean here, right? Uh, so, so what we have to do here, and what we have to do is you have to figure out whether or not the line is starting from rest or coming to rest. What does that mean though? That means nothing to you. So let's take a look at this first graph. As you can see, the line kind of starts like that, starts like a vertical line. You kind of curve, you arch, and you curve. And then as I extend this line to the right, it kind of looks like a flat horizontal line. And what did we say on the position time graph a flat horizontal line represents? It represents you're coming to rest, right? You're coming to rest here. This is what it means to be at rest. So we're coming to rest. And my final velocity here is 0. So if you're coming to rest here, what would we say about the object? Are we starting at rest or are we coming to rest? All right, and well, I already answered it, but if we're coming to rest, are we speeding up or are we slowing down? We are slowing down if we're coming to rest, right? We want our final velocity is 0. Our speed is decreasing. We're slowing down, and I wrote this wrong, but we're slowing down. We're slowing down here, right? And so let's take a look at the graph to the right. So our graph to the right kind of looks like it's starting from rest, because you can see that horizontal line, and at the end here you see the line going downward. So you can say that, well, I'm starting from rest here at a time of 0, starting from rest. I'm starting from rest. Starting from rest. And that says my initial velocity is 0 here. And well, if I'm starting from rest, if I'm starting from an initial velocity of 0, well, that means I'm speeding up, right? As you see the slope curve, I'm essentially speeding up. Let's take a look at the bottom left graph. Let's take a look at the bottom left graph. So the bottom left graph kind of looks like you're starting from a vertical line, and then you're kind of ending like that. So you can kind of say that, well, my velocity here, my final velocity is 0, and I'm essentially coming to rest. I'm coming to rest here. And if you're coming to rest, well, that essentially means that you're slowing down. So this graph essentially means you're slowing down. And then we do the final graph here. Let me use brown. So it kind of looks like we're starting from a horizontal line. So that means my initial velocity is 0, and I'm starting from rest. And I'm essentially speeding up. Just speeding up. Okay? That's essentially what this means and how you interpret graphs like that. If you need some time to analyze this, please feel free to pause the video. All right? So let's go into box 3, or rather, slide 3. So we have this velocity time graph here. We have this velocity time graph here. And the slope of a velocity time graph, the slope of velocity time graph is essentially is your acceleration. Because again, if you think about it, you have your slope, it's delta y over delta x. Your delta y is velocity, and you measure velocity in meters per second, and your x is time, and you're doing it over x. And in math class, if you learn that, well, if you're dividing by a unit or on the bottom, divide by something on the bottom, you'll define a fraction, but you're multiplying essentially by its reciprocal, which is multiplied by 1 over s, which is essentially what this is. And you get meters per second squared. Now, what is this a unit for? This is a unit for acceleration. So you know that the slope on a velocity time graph gives you acceleration. You can either just remember this or remember proof, either one, as long as you know that the slope of the velocity time graph gives you acceleration. So now we want to label parts of our graph that represent positive acceleration and negative acceleration. So again, we talked about this, right? This is a downward slope, means you have a negative slope. Right? So this is negative slope. I should probably use a different color. Right? So negative slope, this is a negative slope here. And this would be a positive slope. A positive slope. Positive slope there. So again, well, if you have a negative slope, you have a negative acceleration. And if you have a positive slope, you have a positive acceleration. And there's not enough room for me to write it here, so you're gonna have to settle for the abbreviation. But that's essentially what it is. So those are my negative acceleration parts, and those are my positive acceleration parts. So what does a velocity of zero mean? A velocity of zero means that you're not moving, right? So you're standing still. It means you're at rest. And so now the question here says, we'll label the parts that represent speeding up and slowing down. It might be hard to kind of look at this without numbers. Well, you can kind of assign numbers here. So let's say this is 5, and then 4, and then 3, and then 2, and then 1. Well, if you look at the first half here, you'll see that my velocity goes from 5 to 4, right? To 4, to 3, to 2, to 1, and then 0, which essentially means that you're slowing down, right? So this part means that you're slowing down. And this part, well, you can clearly see that my velocity is increasing over time, which means I'm speeding up during this part, right? You can definitely see the numbers increasing, or rather the line is going away from 0. So it means you're speeding up. So the velocity here, the question says, is the velocity here positive or negative? My velocity here is positive. You know it's positive because it's above the 0, right? Because this is a velocity time graph here. And we know that any number above 0 is going to be positive. Now the question here says, well, what are the signs of your velocity and acceleration for speeding up and slowing down? In the other slides, we calculated, well, this part means slowing down, right? So this is slowing down. And the other side meant speeding up. Now, we know my velocity here is positive for both times. We know my velocity is positive for both situations. We don't have positive velocity there. But again, my acceleration here is negative. It's a downward slope here, right? Because this is a downward slope, so I have a negative acceleration here. And since this is an upward slope, we can say that my acceleration here is positive. And we talked about this in one of those previous slides. A downward slope means you have a negative slope, and a negative slope means you have a negative acceleration. A positive slope would mean you have a positive acceleration on a velocity time graph. And so this is a concept you guys have learned in unit 1. We didn't talk about it too deeply, but you did learn in unit 1 and unit 2. So the signs of your velocity, if you're speeding up, must be the same. Signs of velocity and acceleration must be the same. They must have the same signs. Must have the same signs if you're speeding up. And if you're slowing down, they must have opposite signs, as you can clearly see here. Clearly see. And this is essentially a summary. What do you guys think this graph is saying? Right? This graph is saying that your velocity essentially changes, it increases, your velocity is increasing, and then slowly and then coming to a stop, which is your velocity, or rather, it's coming to its max velocity, right? So it's coming to its max velocity of, I don't know, like 5 meters per second, and then it's slowly slowing down as it goes back to 0. So it starts from rest, increases its speed, comes to a max speed of, I don't know, like 5 meters per second, and then slowly decreases its speed until it comes to rest. So that's essentially the motion of the cart. Let's go over the practice questions. Let's go over this one. So this question says, which pair of graphs represent the same type of motion? Well, let's look at choice A. All right, let's look at choice A. So this PT graph right here, the PT graph, displacement versus time graph, it seems like you have a constant slope. Right, I have a constant slope over here, which means I have a constant velocity. And my velocity time graph here is saying that, well, it's saying the same thing, right? My velocity is constant. My velocity is essentially constant here. My y-axis is velocity, so I'm staying at a particular velocity over time. So this is also saying that I have a constant velocity. And so we now just finished answering the question. The answer is choice A. But let's not make it that easy for us, right? Let's try and analyze the other graphs first. So let's look at the PT graph for B. B is saying that you have a negative slope, right? So it's a constant, a negative slope. Constant negative slope. Which means you have a negative velocity, right? A constant negative velocity. But if you took a look at your velocity time graph, your line here indicates that, well, my velocity here is constant. Oh, rather, no, I'm sorry. Scratch that. My velocity here is positive. It's above the 0. And anything above the 0 is going to be positive here. So it's saying that I have a positive velocity, which is clearly not the answer here. Clearly, we're saying in B is saying I have a negative velocity, whereas the velocity time graph here on the right says that you have a positive velocity, so B is not the right choice. C is saying that you have an object that's clearly at the same position over time. So C is saying that your object here, your PT graph, says it's at rest. But if you look on your velocity time graph, you can clearly see that, well, Sure, at the beginning my velocity was 0, but my velocity is increasing over time. It's increasing over time, so my velocity is changing here. My velocity is changing. So clearly, you're not at rest. D is saying pretty much you have a constant slope, which essentially means you have a constant velocity. Oh, a constant velocity. But this VT graph on the other side is saying that, well, you also have a constant slope, but a slope on a VT graph gives you acceleration. So you're accelerating here, which is definitely not constant velocity. You'd expect constant velocity to be a straight line like that. So yeah, that's not the correct answer. So the only answer here is A. So the other ones don't make sense. Again, if you want to pause the video, analyze it, well, just rewind and pause it. Let's take a look at this question. For B, which graph represents the motion of an object traveling with positive velocity and negative acceleration? Right? So positive velocity and negative acceleration. If you have a velocity and you have an acceleration, that means your object is obviously your object is accelerating, but if your object is accelerating, your position time graph will curve. So it's neither A nor C. Your slope must curve, your slope must change. You must have a changing slope if you have an acceleration. So now we have to first off figure out, well, is this object coming to rest or starting from rest? We have opposite signs. We have a positive velocity and a negative acceleration, which means we have opposite signs here, which means we are slowing down. And which one of these graphs kind of resemble you slowing down? Well, this graph right here kind of looks like you're coming to rest, right? So you're coming to rest here. So essentially this means that you're coming to rest, so you're slowing down. And the bottom one, D, is saying you're starting from rest, right? Because you see this. So it's speeding up. So the answer here is B. The answer is B. Which paragraphs represent the same type of motion? So we're going back to this. A is saying that your object is accelerating, right? Because you see that curve. And here, velocity time graph is saying that you have a constant slope, which means you have a constant acceleration. So already right off the bat, it seems like A is the correct answer. Let's take a look at the other answer choices first. B is saying that you're going from a negative direction to the positive, which means you do have a positive velocity here. So, but you have a constant positive slope. You have a constant positive slope here, which is essentially saying that you have a constant positive velocity. But this VT graph on the other side says you have a constant negative velocity because you're below zero. So B is not right. They don't really match. C is saying that you have a constant negative slope. You have a constant negative slope here, which means you have a constant negative velocity, right? Constant negative velocity. right? So we have constant negative velocity here. But this VT graph here says that your velocity is changing, so you have a constant positive slope. So you have a you have a constant slope, and that means that my object here is accelerating, right? So there's acceleration here, which means that this velocity is not constant. A constant velocity would be a straight line at a certain point, but it's not. So C is definitely not the answer. D disposition time graph is saying that your object is accelerating because you see the curved slope. So you're accelerating here because you see the changing slope here, the curve. But if you look on your velocity time graph, clearly your velocity time graph is saying it's constant velocity, which means that your acceleration here is 0. So the only choice here is choice A. Feel free to again go back and pause the video if you need to look at it further. This is the end of the video.